Project requirements, the key to a successful project conclusion. The requirements process is the activity of identifying and communicating what the users want and why they want it. When this information has been accurately and efficiently communicated, the project team can produce an optimal solution that provides maximum usability to the user with minimum development effort. Unclear or ambiguous requirements can often be worse than not having any requirements at all. An ambiguous requirement can leave the developer with the impression that they understand the requirements, when in reality their understanding may be completely incorrect. The more complete the requirements for the project, the better position the development team will be in when unexpected events occur during the project or when additional questions are raised. Let's start by looking at ambiguity. Ambiguity in a project requirement can easily lead to error due to misinterpretation and misunderstanding. So how much does a mistake actually cost? Software is one of the easiest things to change after development is completed because it has no physical form. And yet, formal studies have shown that the cost of detecting and correcting errors in software jumps dramatically the later in a project that the error is detected. As this chart shows, errors in a software project can cost 40 to even 1,000 times as much to fix once the project is completed as they would cost to fix during the requirements phase. In other words, whatever you need to do to make sure the requirements are correct is effort well spent. And this data is for a software program which is relatively easy to fix. Think of what a major recall can cost an automaker. Where does ambiguity come from? There are three main sources, and each of these will cause different types of errors. There are observational, recall, and interpretational. Observational and recall errors typically cause small variations in the results, whereas interpretational errors can cause large variations in results. Think of the classic stories about someone who is granted 3 magic wishes. Typically, the wish is poorly specified, and the end result usually meets the letter of the wish while managing to dreadfully miss the actual desired results. So far, we have talked about the importance of detailed requirements in any project, but there can be such a thing as too many details as well. People tend to pay attention only up to the point where they feel they understand what is being communicated, and they stop listening after that. They also tend to remember only the parts that they felt were important. Once they believe they understand the project requirements, they generally work from memory for those requirements, while only rarely actually referring to the documented requirements themselves. The simpler the requirements are, the more they will be remembered. Requirement specification is an art of compromise between too little detail and too much detail. Requirements can be classified into 4 main groups: functions, constraints, attributes, and preferences. Functions are the basic features of the product and describe what it does. Functions can be classified, based on input from the user, into 3 main categories: evident, hidden, and frill. Evident functions are those that the user needs to know about. For example, a project might be started to design a new toaster. Designing the toaster is an evident function of the project. Hidden functions are those that need to be performed, but the user doesn't necessarily see it. In our example, the client might also wish to employ local contractors to build prototypes. That is not visible, but it is still a requirement. Frill functions are those that might be nice, but the user doesn't really care about. A frill might be to use existing client office space, but if that's not feasible, then it's okay to use new space. A clear understanding of the attributes allows the project team to make trade-offs. Attributes are dimensions that describe how the project does what it does, as opposed to what it does. They can be classified by the user into 3 main categories, typically described as must, should, and could. Must means something that is very important to the user and is key to the success of the project. If the project is being conducted for a French company, then a must attribute might be to generate project reports in French. Should means something that is important to the user, but not key to the success of the project. It might be useful to have project reports available online, but not essential. Could, of course, applies to attribute details that would be nice, but are not important enough to sacrifice other details or expend any significant effort upon. It might be nice to have reports updated every hour, but only if that can be done with minimal effort. Constraints actually apply objective bounds to the attributes that have been identified. This makes the results more predictable and helps reduce subjective influences during the design process. A constraint might be to specify the maximum length of time that a project has to be completed in. This does not always follow from an attribute. If a project is working to overhaul a fleet of snowplows, for example, and it is completed in July ahead of schedule, there is little benefit. But the project must absolutely be complete before the first snowfall. Preferences form the wish list. It is helpful to know what the customer prefers so that the development team can provide enhancements at little or no effort when the opportunity arises. For example, if we know that the customer's favorite color is red, we can use that color in the project when an arbitrary color choice needs to be made. This otherwise arbitrary decision can be made to fulfill a preference without incurring any extra development overhead. Once the project requirements have been identified and documented, the review process forms the closure of the loop. The customer must review the final requirements for accuracy, and the project specification must be reviewed against the requirements. The requirements should be subject to testing just as if the project was already complete. Take a sample of common problems, or input data in use models, and perform a verbal what-if walkthrough based on the requirements. In conclusion, requirements form the key decisions about the product and will make or break its success right from the start. The amount of effort put into the requirements phase must be appropriate for the project. Requirements gathering for a new toaster is very different from requirements gathering for a new satellite. Likewise, the cost of poor requirements must be weighed. Too many requirements gathering processes are ad hoc at best, and the quality of the results is often extremely poor. Thorough research, validation, and communication are essential to an effective project conclusion.